Um, you know, usually when you think about typing on a keyboard or really just interacting with a computer in general, there's this underlying expectation of, well, total emotional detachment.
Right, it's very binary.
Exactly. It's an entirely binary relationship. You press a key, the letter pops up on the screen, you hit send, the message just goes out into the void. The machine does not care if you're, like, calmly typing a well-thought-out email with a cup of coffee in hand or furiously mashing the keys because your Wi-Fi just crashed and you're 5 minutes late for a deadline.
Yeah, to the machine, historically, a keystroke has just been a keystroke. I mean, it's a mechanical input, completely devoid of any human context.
Yeah.
We input the data, the computer processes it, and it outputs a result. That's it.
And we've all just kind of been conditioned to accept that, haven't we? Like, we actually adapt ourselves to the machine's rigid way of communicating rather than the other way around.
We absolutely do.
But, so I was reading through these stack of materials we have on the desk for this deep dive. We've got the architectural documentation from the HumAIne project, the technical specs for Stencil, and this fresh 2025 research paper by Makritis and your team. And looking at all this, it seems like that cold mechanical keyboard is essentially becoming obsolete. We are suddenly looking at a landscape that is starting to read our digital body language in real time.
It really is a massive paradigm shift in how we approach human-computer interaction. As the lead researcher on the HumAIne project, the core problem we set out to solve was exactly what you just described. The machine is finally being forced to adapt to the user.
Wow, okay.
Yeah, we are trying to build systems that don't just process your text, but actually understand the cognitive and emotional state you are in while you're producing that text.
Which is such a wild concept to wrap your head around. I want to really dig into the mechanics of this today because by the end of this deep dive, I think you, the listener, are going to look at your everyday typing habits in a completely different light.
I certainly hope so.
But before we get into the crazy metrics of how a computer knows you're stressed just by, how fast you hit the spacebar, we need to talk about why current chatbots, even the really advanced ones, still feel so incredibly impersonal. Like, if I ask a standard customer service bot a question today, I almost always get this generic wall of text that just makes me want to pull my hair out.
Right, and the frustration you're feeling there is actually the friction between two different eras of technology. We're currently transitioning from what engineers call Industry 4.0 into Industry 5.0.
Oh, Industry 4.0. I've heard that term thrown around a lot in corporate keynotes. That was essentially the big push into the Internet of Things, cloud computing, massive data, automated, all that stuff, right?
That's the core of it, yeah. Industry 4.0 was all about automation, efficiency, and system-centric AI. The overarching goal was really to make machines faster and more capable of handling massive data sets.
Usually to replace human tasks, right?
Exactly, often with the intention of replacing human tasks entirely. But it hit a wall when it came to nuanced human interaction. It prioritized the system over the user. Industry 5.0 is, it's basically the necessary correction to that.
Interesting. How so?
Well, it's trying to bring human, social, and even environmental context back into the loop. The focus is now on collaboration between humans and machines, recognizing that technology should adapt to the worker or the user, not just force the user to become a node in a highly efficient network.
So it's moving from, like, how fast can the machine think to how well can the machine understand the human using it?
Exactly that. And in the world of conversational AI, Industry 4.0 thinking created two massive flaws, which we outlined in our Makritis paper.
Right.
First, there's a severe lack of true personalization. Current systems offer generic responses that completely ignore your unique characteristics, your background knowledge, or your current mood.
Okay, and the second flaw?
Second, there's a lack of user-centric evaluation metrics. The tech industry has been overwhelmingly obsessed with whether an AI can pass a Turing test, whether it sounds indistinguishable from a human.
Sure.
But they haven't actually figured out how to measure if the human on the other side is actually motivated, understood, or satisfied by the conversation.
Wait, I actually have to challenge that premise a bit.
Yeah.
Because if I go use the latest version of, say, ChatGPT or Claude right now, it already sounds incredibly human. I mean, it can be witty, it can be apologetic. Why do we need a whole new architectural framework from the HumAIne project just to make it sound more human?
That's a great question, but sounding human is not the same thing as being personalized to a specific individual in real time.
Oh, okay, I see.
You're right that current large language models, LLMs, generate incredibly coherent, contextually rich dialogue. But their approach to you is entirely static. When you open a fresh chat window, that AI doesn't know if you're a senior software engineer looking for a highly technical breakdown of a coding error, or, say, a stressed-out beginner who just needs the absolute basics explained as simply as possible.
Right, it just kind of guesses based on the prompt.
Exactly, it just defaults to its median training style. So the HumAIne chatbot is a completely new framework designed to bridge that specific gap.
Yeah.
We built an AI-driven user profiler and a prompt curator that work together to dynamically adjust the underlying AI's response to fit your current psychological state.
Ah, okay, I see the distinction now.
Yeah.
So relying on a standard LLM is basically like buying a one-size-fits-all poncho.
A poncho.
Yeah. Like, it keeps the rain off. It technically does the job of a coat, but it's not exactly flattering or tailored to your specific body type.
Mm-hmm.
But the HumAIne project is essentially trying to build an invisible AI tailor that measures you and stitches a custom suit for you in real time, right in the middle of the conversation.
Yes. That analogy captures the goal perfectly. The system is constantly taking your measurements, so the fit is always perfect, even as your needs change from minute to minute.
But that brings up the obvious problem, doesn't it? I mean, I don't want to be measured if I'm trying to figure out why my router isn't working. I do not want to fill out a 20-page psychological evaluation survey before the bot will talk to me. How on earth does your system figure out my expertise or my mood without annoying me with endless questions?
It all comes down to the shift from explicit metrics to implicit metrics.
Okay.
Explicit metrics are those annoying surveys you just mentioned. They are the pre-session questionnaires, the direct feedback forms, or when a bot asks you to click a thumbs up or thumbs down after it gives you an answer.
Which nobody ever clicks.
Right, exactly. Now, we do use a tiny bit of explicit data, maybe asking 2 or 3 very quick, targeted questions before a session just to set a baseline. But the heavy lifting, the real magic of the HumAIne system, relies entirely on implicit metrics.
Which is that digital body language we talked about earlier.
Yes. Implicit metrics allow our system to gather data without you ever having to actively provide it or break your workflow. We are analyzing the mechanics of your interaction, how you type, what you type, and the structural patterns of your text.
Let's dive into the actual mechanics of that, because looking at the metrics from your research, this is where it gets incredibly fascinating and maybe a tiny bit creepy. What exactly is the HumAIne bot tracking under the hood while I'm angrily typing away at it?
Well, we track several highly nuanced signals simultaneously. The first is typing speed, which we calculate as characters per second. The system measures the exact delta from the moment you initiate the first keystroke to the moment you hit send.
So it's not just looking at the final message, it's looking at the hesitation. Like if I take 3 minutes to type a 12-word sentence, it knows I'm either distracted or struggling to formulate my thought.
Precisely. And conversely, if you fire off a 50-word response in 10 seconds, it indicates high confidence, urgency, or possibly frustration. Then we correlate that with the second metric, which is grammatical mistakes frequency.
Okay.
The system calculates the number of grammatical errors per word.
Wait, if I'm typing fast and making typos, isn't that just because I'm on a phone or I have clumsy thumbs? How does the bot actually know I'm stressed?
That's where context and baselines are key. Cognitive load theory shows that when human beings are overwhelmed, stressed, or emotionally taxed, our working memory capacity drops.
Oh, wow. I didn't know that.
Yeah, and one of the first things to degrade when your working memory is overloaded is fine motor control and secondary rule adherence, like grammar and spelling.
That makes so much sense.
Right, so if your baseline interaction shows you normally type quite cleanly, but suddenly your error rate spikes alongside an increase in typing speed, the system recognizes a high probability of stress or cognitive overload.
Okay, yeah, you're losing the bandwidth to care about punctuation because you just need the problem solved right now.
Right.
What else is it looking at?
The third major signal is the complexity of language. We measure your average sentence length and calculate something called the type-token ratio.
Type-token ratio. Break that down for me.
It's a linguistic measure of vocabulary richness. It compares the number of unique words you use, those are the types, against the total number of words in your message, the tokens.
Oh, okay.
If you use a high ratio of unique, complex words, it signals subject matter expertise and a calm, deliberate state of mind. But if you are just repeating the same basic vocabulary over and over in short, choppy sentences, it suggests you might be a novice or, again, under stress. And finally, we run real-time sentiment analysis on the actual text to gauge the emotional tone, whether the words themselves skew positive, negative, or neutral.
Okay, I have to pause you right here because my inner privacy advocate is just screaming. Like if I'm chatting with my internet provider or a health portal, I might not consent to their server psychoanalyzing my typos to figure out if I'm having a bad day.
Mm-hmm.
That level of behavioral tracking feels incredibly invasive.
You are touching on the exact vulnerability and ethical concern we debated constantly during development. It's a very valid reaction.
It's scary.
It is, but the crucial safeguard here is that this implicit data is extremely localized and ephemeral. We aren't building a permanent, cross-platform psychological dossier on you.
Okay.
The interaction tracking engine is simply looking at session-based states to optimize that specific conversation. Once the session ends, the nuanced keystroke telemetry doesn't need to be tied to your permanent identity.
Okay, that makes me feel slightly better. It's reading the room in the moment, not following me home. So you have all this real-time data, my speed, my typos, my vocabulary richness. How does the bot actually use that to change its behavior? Because just knowing I'm stressed doesn't automatically write a better response.
Right. And that is where we introduce the brain of the operation. It's a reinforcement learning algorithm called Proximal Policy Optimization, or PPO. We feed all these implicit metrics into PPO, and it dynamically adjusts how the bot communicates.
Reinforcement learning always sounds like magic to me. Explain how PPO works in plain English. Like, how does it actually learn what to do with my typos?
Think of reinforcement learning like training a dog using a reward system. If the dog sits, you give it a treat. Over time, it learns that sitting is a highly valued action.
Right.
But an AI doesn't eat treats, it optimizes for mathematical rewards. In the HumAIne system, every time a user interacts with the bot, it's treated as a learning episode. The system observes the state, which is your current stress level, language complexity, and sentiment. Then, the bot takes an action.
What kind of action?
It chooses to adjust its response by making it more technical, shorter, more empathetic, or maybe highly detailed.
And how does it know if it took the right action?
We define a reward function based on engagement signals. If the bot gives you a short, direct answer, and your subsequent typing speed normalizes, your grammatical errors go down, and your sentiment score goes up, the algorithm receives a positive reward value.
Oh, wow.
It mathematically registers, when the user is exhibiting high-stress implicit signals, providing concise, simplified answers yields a better human state.
So if I'm furiously firing off rapid, typo-ridden messages, the bot basically acts like a really good bartender. It realizes I'm agitated, drops the long conversational essays, and just gives me the digital equivalent of a stiff drink, a short, direct, actionable answer.
That is precisely the mechanism at work, and the word proximal in proximal policy optimization is vital here.
Why is that?
In machine learning, if an algorithm discovers a new trick that gets a high reward, it can sometimes overcorrect wildly. If the bot suddenly flipped from sounding like a hyper-professional lawyer to a casual teenager using slang in the span of one message, it would be incredibly jarring and destroy user trust.
Oh, yeah, that'd be weird.
Right. So the proximal constraint essentially clips the algorithm's updates. It forces the bot's behavioral shifts to be gradual, smooth, and natural, maintaining a consistent persona while subtly altering the vocabulary richness and sentence structure over the course of a few messages.
Which sounds incredibly complex to pull off in real time. I mean, from a structural standpoint, if your system is capturing micrometrics like the millisecond delay between my keystrokes, running that through a reinforcement learning model, and dynamically rewriting prompts, the underlying architecture has to be unbelievably fast.
It does.
Because as a user, if I hit send and my browser lags for even half a second while your engine psychoanalyzes my grammar, I'm just going to close the tab. How do you run that level of tracking without destroying the website's performance?
That was definitely the biggest engineering hurdle. You need deep tracking logic, but it must remain entirely invisible to the user's browser performance. We solved this using two things, the C4 architectural model and a specific compiler technology called Stencil.
Okay, let's break down the C4 model first. What does that architecture actually do?
So the C4 model, which stands for context, containers, components, and code, is a way of deeply separating the concerns of the system into distinct layers. We specifically isolate the heavy lifting. On the front end, in the user's browser, we only run the interaction tracking engine.
And what does that do?
Its only job is to quietly listen to keystroke events and fire off tiny asynchronous data packets to the backend. It does zero analysis itself.
So the browser is just acting as a lightweight microphone.
Exactly. All the heavy psychological analysis happens on our secure backend. That data flows into the AI-driven profiler, which updates your state. Then the profiler sends your parameters to the prompt curator.
Okay, the prompt curator, this is the piece that intercepts my question before the AI even sees it.
Yes. You might type a simple prompt like, how do I fix error code 404? The prompt curator grabs that, looks at your dynamic profile, and silently enriches your prompt behind the scenes.
Sneaky.
It wraps your question in hidden instructions, basically whispering to the underlying large language model. The user asking this is a highly stressed novice. Ensure the response uses a low type token ratio, short sentences, and a highly empathetic tone.
The brilliant part of that design is that your system operates completely independently of the underlying LLM itself. The research notes that because you are just curating the prompt, you can seamlessly swap out OpenAI's models for Google's Gemini or Meta's Llama, or even a proprietary local database. The HumAIne architecture just sits on top of whatever brain a company wants to use.
Which future-proofs the entire system. As foundational AI models evolve every few months, the personalization framework we've built remains perfectly intact.
Now, regarding that ultra-fast front end, you mentioned a technology called Stencil. If I'm a developer at a mid-sized company and I want to put this smart chatbot on my website, do I have to rewrite my entire application in the specific framework to make it work?
No, and that is exactly why we chose Stencil. Stencil is not a traditional runtime framework like React or Angular, which come with a lot of heavy JavaScript overhead and sort of dictate how your whole app must be built.
Right.
Stencil is a compiler. We write our user interface using modern development languages, TypeScript and JSX, and Stencil compiles that code into 100% standards-based vanilla web components.
Meaning it works natively in any browser without needing special libraries.
Precisely. Because it generates standard web components, it is entirely framework agnostic. We export these components using an output target called dist custom elements. A developer can just take our custom HTML tag, drop it into their existing site, whether it's built on WordPress, Vue, React, or just plain HTML, and it immediately functions.
But how does it handle that front-end tracking without blocking the main thread of the website? I mean, web performance is everything. If your chat widget slows down my homepage loading speed, I'm not using it.
Stencil handles this beautifully through an asynchronous rendering pipeline and out-of-the-box lazy loading. When you put the HumAIne component on a website, Stencil provides a tiny bootstrap script.
Okay.
It registers the presence of the chatbot on the page, but it deliberately defers loading the heavy JavaScript required for the interaction tracking engine until the precise millisecond the user actually clicks into the chat window to engage.
That is incredibly elegant. It costs the website almost zero resources until the user actually demands it.
Exactly.
But this brings me back to my privacy freakout from earlier, which leads to the most fascinating part of your research paper. You've built a hyper-personalized AI that tracks human behavior intimately, reading stress and expertise through keystrokes. How on earth did your team safely train and test a reinforcement learning model on sensitive emotional data without violating the privacy of hundreds of human test subjects?
That is the ultimate ethical minefield of Industry 5.0. To train an algorithm like PPO, it needs to fail, learn, and adjust thousands of times. If we ran those early trial and error tests on real humans trying to manipulate their satisfaction by reacting to their implicit stress signals, we would face massive privacy risks.
Oh, for sure.
Not to mention complex institutional review boards and severe participant fatigue. Plus, there is the Hawthorne effect.
Remind me what that is.
It's the phenomenon where real humans act differently and type unnaturally simply because they know a lab is monitoring their keystrokes.
Oh, right. So how did you gather the data to prove this actually works?
We bypassed real human testing in the initial phases entirely, using a novel approach we call the virtual XAI framework. Instead of recruiting 50 real people to sit in the lab, we used GPT to generate 50 highly detailed, diverse synthetic personas.
You essentially built 50 synthetic guinea pigs.
We did. We engineered deep digital backstories for each of them. We created a perfect cross-section of a user base. We had synthetic personas with ages ranging from 18 to over 65. We gave them varied education levels, from high school diplomas to PhDs. But most importantly, we programmed them with strict behavioral constraints that mimic the implicit metrics we track.
Give me an example of how you tell an AI to act like a specific human typing at a keyboard?
Sure. So in the system prompt for a persona, we would instruct it. You are an impatient, stressed corporate manager. You type very quickly, you use short, aggressive sentences, and you make frequent grammatical errors because you are rushing.
Wow.
And for another persona, we might say, you are a highly anxious senior citizen who is a complete novice at technology. You type very slowly, you use a limited vocabulary, and your sentiment is highly hesitant. We essentially simulated different emotional and cognitive profiles interacting with our bot.
It's basically a flight simulator for artificial intelligence. Like, you let your experimental HumAIne chatbot crash, burn, make mistakes, and learn 150 times with these digital ghosts. So by the time it actually gets deployed and talks to me, it already has incredible bedside manner.
That is exactly what it is, a safe, controlled sandbox. We ran 150 simulated sessions across 10 different conversational domains, things like personal finance, health and wellness, career development, and complex technology troubleshooting. And the empirical results were staggering.
Yeah, the Magri's paper has the data on this. Let's look at the actual improvement you saw from this flight simulator.
When we compared the HumAIne system's performance against a baseline, non-personalized LLM chatbot, our system produced a massive 45% increase in overall user satisfaction across the synthetic personas.
A 45% jump just from reading implicit cues and adjusting the tone. That is a colossal leap in user experience design.
It's transformative. And the gains varied by domain in really revealing ways. The highest improvements weren't in basic tech support, they were in domains requiring high nuance. For instance, professional networking or creative projects saw a 50.3% increase in satisfaction.
Which completely tracks with human psychology. If you're brainstorming a creative project or trying to figure out how to navigate a delicate career move, you desperately need a partner who understands your specific vibe, your expertise level, and your current anxiety.
Exactly.
A generic textbook response in those situations is worse than useless.
Precisely. Our prompt curator adapted the language complexity and style consistency so accurately that the synthetic personas registered significantly higher task achievement scores. The bot didn't just sound nice, it actually helped the user solve their problem faster.
That's incredible.
And we achieved this massive leap in capability with zero privacy risks to real people, zero need to harvest actual user data for training, and no ethical compromises. It proves you can pre-train a deeply empathetic adaptive AI safely before it ever touches the real world.
This entire deep dive has been incredibly eye-opening.
Yeah.
We started by looking at this macro shift toward Industry 5.0, where we are desperately trying to force our cold, mechanical systems to actually care about the human context. We explored the subtle magic of implicit metrics, how your raw typing speed, the frequency of your typos, and the richness of your vocabulary act as a digital body language that the HumAIne Project's AI profiler reads natively.
Yes.
We broke down how incredibly efficient the Z4 architecture and the Stencil compiler are, allowing this heavy psychological tracking to happen invisibly without slowing down your web browser. And finally, we saw the absolute genius of using synthetic personas as a flight simulator to safely map out the ethical boundaries of personalized AI.
The ultimate takeaway is that it fundamentally changes the relationship between user and machine. The chatbot is no longer just a static, unyielding tool you have to learn how to use. It is an active, dynamic conversational partner that learns how to work with you.
It really is a whole new era. I want to remind you, the listener, that the next time you open a chat window to argue with customer service or to casually brainstorm a weekend project, the little cursor blinking on your screen might literally be reading your mood. It might be calculating your characters per second in real time to decide just how gentle or direct it needs to be with you today.
Which is, in many ways, a deeply comforting thought. We are finally building technology that has the capacity to empathize with your current state of mind.
It is comforting, but it also leaves us with a lingering question to chew on, something that isn't explicitly laid out in the research but stems directly from this new power. If an AI can perfectly map your emotional state, your vulnerabilities, and your stress levels just by analyzing the cadence of your typing and the complexity of your grammar, what happens when this exact same technology is used not to give you better tech support, but to perfectly tailor a high-pressure sales pitch or a targeted political argument, entirely optimized to your current psychological state?
When you connect this capability to the broader landscape of persuasive technology, the ability to adapt to a user's emotional vulnerabilities in real time is an immense and slightly terrifying power.
Just something to mull over the next time you find yourself furiously mashing the keys. Suddenly, that jagged white line of text on your screen isn't just a record of what you typed. It's a real-time psychological X-ray, showing exactly how you felt when you typed it.